Hello students, welcome back to the sixth video of this playlist. So in this video we will be solving the sixth question from statistics 1, that is S1 January 2024 paper. So let's see what's the question number 6 from this paper is about. So basically the concepts behind this question is from chapter number 4, that is probability chapter of your statistics S1 book. So to be more specific, you should have idea about conditional probability, Venn diagrams also, and intersection and union of events, and also some concepts from pure maths, that is solving and dealing with simultaneous equations will be also needed here. So let's get started with question number 6. Okay, the events A and B satisfy probability of A, that is X, probability of B, this is Y, and probability of A union B, this is 0.65, and probability of B given A, this is 0.3. Okay, fine, these are the details given about this question. Part A asks here to show that 14x plus 20y equals to 13. We need to show that 14x plus 20y it's what? 13. Okay. So how can we start this? Look, we know probability of A union B is given, right? So if you consider using a Venn diagram, that would be more easier for you to understand the scenario. So let me draw a Venn diagram for this case. So this is the circle with A, it represents A. Okay, this is A, and okay, this is B. Let me displace their position. Okay, they will have an intersection, right? Because there is a value for probability of A given B, right? So this will have intersection. Okay, so since they have intersection, how do I understand that they will have an intersection? Because B given A, that means some part of B is within A. So this is A, this is B. Okay, now for part A, so what's the formula? We know that. What's the formula for A union B? Probability of A union B, this is equals to what? Probability of A plus probability of B minus what? Why minus? As you consider probability of A, the whole part is getting considered once, right? Again, when you consider probability of B, this part is coming with that, this intersection is also coming. So basically the intersection part has been considered twice. So in order to balance it, we subtract probability of A intersection B. So there's nothing to memorize. The formula is not required to be memorized. You need to understand the concept behind it. Okay, so we know that probability of A is X, probability of B is Y, but what is probability of A intersection B? Is this one? Nope, that's not that. Okay, why? Because probability of B given A, but yeah, we need to use the concept from this one. Probability of B given A is basically what? Condition is out of A, how much part of B is there, right? This is B intersection A. This is probability of B given A. So using this, the value for the probability, that is B given A, we know this is 0.3, so we can use this, isn't it? So probability of A intersection B over probability of A is what? X. This is equals to what? 0.3, right? Okay, so probability of A intersection B can be written as what? 0.3 X cross multiply. Then so we got the value for probability of A intersection B. Therefore what we need probability. Okay, we need the equation. A union B, right? So what we can write, probability of A, that is X, plus probability of B, this is Y, minus A intersection B, this is 0.3x, it is equals to how much? 0.65. It's given in the question, right? Okay, this is 0.65. Okay, so x minus 0.3x, so this is 1 minus 0.3, which is 0.7x, plus y equals to 0.65. okay, so basically what we can do, we can multiply both sides by 10. okay, so if you multiply both sides by 10, you will get 7x plus 10y equals to 6.5, right? 6.5. okay, now what we can do, we can multiply both sides by 2. 6.5 times 2 will give 13, right? So you'll get 14x plus 20 equals to what? 13. And that's what the question in part A has asked for, right? Okay, done. Next is part B. okay, before part B, the events B and C are mutually exclusive such that even B and C are mutually exclusive. That means what it would be the position of C? It would be what? It will be there, right? Okay, so we don't know exactly like whether A will have intersection with C or not, so we can consider it can be here. Okay, since they didn't mention that A and C is mutually exclusive or not, so we will consider they have intersection. So this is C, fine. Okay, but there should be no intersection between B and C because they are mutually exclusive. So B union C is given 0.85 and probability of C is given, this is half of x plus y, fine. Okay, for part B, 1, find a second equation in x and y. We need to find out a second equation in terms of x and y. Okay, so B union C is given, right? And probability of C is given, and we know that probability of B is basically y. So since they are mutually exclusive, so we can use this concept, right? We can use this concept that for part B1, since the two events are exclusive, mutually exclusive, so probability of B plus probability of C, right? So probability of B is what? Y, and probability of C is what? Half of x plus y, right? So this can be written equal to how much? It is 0.85, right? Okay, so this is 0.85. So let's proceed for the second equation in terms of x and y. It will be half of x plus twice of y. This is equals to 0.85. So what we can do now is that we can multiply both sides by 2 to remove the fractions. So x plus 4y equals to what? 0.85 times 2, it is what? 1.7, isn't it? 0.85 times 2, this is 1.7 exactly. So 1.7. Now you can multiply both sides by 10. So you will get 10x plus 40y. This is equals to 17. Okay, just I multiply both sides by 10 to remove the decimal. Okay, so this is the equation, another equation, the second equation for the case in terms of x and y. Now part 2, they asked to find the value for x and y, right? Find the value of x and the value of y. Okay, so we need to find out the value for x and y. So what I said, simultaneous equations, right? We just need to solve the two simultaneous equations. So here it is 10x plus 40y. It is what? 10x plus 40y, and previously it was 14x plus 20y, right? 14x plus 20y. Okay, 14x plus 20y. Okay, so what we can do is that, okay, at first let me write the two equations. 14x plus 20y, that would be easier to consider then. This is equals to 13, right? This is the first equation we got. So what we will do is that we can multiply the first equation that we found in part A by 2, okay, and then subtract it from the second equation. This is basically solving simultaneous equations using elimination method. Okay, we will subtract the first equation by multiplying it by 2, so that would give you 28x plus 40y equals to 26. We are subtracting. Okay, so if you subtract, what you will get, negative 18x, like plus 40y minus 40y cancels out. This is equals to what? Negative, how much? It is negative 9. Okay, so the value for x would be what? Half. So we got the value for x using elimination method. Now we need the value for y, so you can put the value for x in any of the equation to get the value for y. So y would be 13 minus 14x. So 13 minus 14x is 14 times half, which is 7. 13 minus 7 divide what? 20, right? The coefficient of y was 20, so here it would be 20. So the value for y is basically 5 over 20. There is 6 over 20. This is what? 3 over 10, right? 6 over 20, which is basically you can say not equivalent, it is basically 3 over 10. So this is the value of y, this is the value of x. Done. Next is part C. For part C, they asked here to determine whether or not A and B are statistically independent. Okay, independent. So what's the process for identifying independent events? For independent events, what we know that for independent events, they said A and B, right? So for independent events, probability of A intersection B would be equal to probability of A times probability of B. So what's the probability of A? We already know that, right? So consider the right hand side. Probability of A is what? X. So x is half, right? And probability of B is what? 3 over 10, which is 0.3, right? So this is equals to how much? 0.3 times half, which is basically 0.15. 0.15. Okay, now consider the left hand side. For the left hand side, this is probability of A intersection B. So probability of A intersection B is given by what? We considered this in part A. A intersection B is given by 0.3x. So 0.3 times x is what? For left hand side, 0.3x. This is equals to what? 0.3 times half, 0.5. This is basically also 0.15. So probability of A intersection B equals to probability of A times what? Probability of B. Hence independent, right? Hence A and B are what? Independent events. That's it. Understand? So basically this is all about question number 6, And yeah, this is all about question number 6, and that's the end of question number 6 from January 2024 Statistics 1 paper.